Welcome, everyone. We'll wait for just a minute to catch any stragglers who are coming in. Welcome, everyone. I'd like to welcome you to the 5th AES Standards webinar. I am Bruce Olson, Chair of the AES Standards Committee, and here is a short introduction to the AES Standards Committee. We are, let's see, there we go. AES is the meeting place for audio professionals. Why do we do AES standards? The business of audio professionals is to supply audio services and to produce the equipment that supports them. Real-world audio systems use components from different manufacturers, and the interface between these components needs to work predictably and reliably. AES standards help to define this interoperability between audio systems components and support the businesses that use them. AES standards are respected throughout the audio community. The AES-SC is comprised of 5 subcommittees, 15 working groups, and numerous task groups. I'd now like to introduce Jeff Berryman, who is Vice Chair of the AES Standards Committee, to talk about audio control in a networked audio world. Go ahead, Jeff.
Unmuting. Thank you. Hi, everybody. I have some slides here to put up on the screen and stuff. Just a little about me. I have a kind of a double background in computing and sound reinforcement. I've been active in computing since about 1968 in university context and business context and stuff. And then I also am a concert loudspeaker designer and designed in the 70s, 80s, and 90s, did a lot of work with major touring artists and so on, designing loudspeakers in my primary area. So I kind of have these two hats, and these two hats converge in AES70. AES70 itself dates back to actually the early 90s when we first started working on a predecessor project called AES24 that never finished, but created a lot of intellectual capital that is now resurfaced and modernized in AES70. So I've been knocking around this block for a while. So here go some slides. Let me put up this presentation. Bang, presentation mode. It's called AES70. What is AES70? AES70 is a control protocol architecture for controlling audio devices on a data network. It allows control and monitoring of audio devices. It works in an object-oriented way, and we'll see a little bit more about what that means. But it contains a large repertoire of control functions that are organized in standardized ways, and it includes an application protocol called OCP.1, which is a definition of message formats that go back and forth along the wire. What is not in AES70, and it's important to understand this, is anything about how to send audio back and forth on the network. That's AES67's job, and we do not encroach on that. What's also not in AES70 is a programming model. In other words, AES70 is not going to tell you how to construct your device, either a hardware or software way. What's also not in AES70 is user interface definition or generation scheme. So AES70 is when you write a controller to control your computer controlled devices. AES70 is not going to tell you what those screens are supposed to look like. What's also not in AES70 are an attempt to standardize the way the audio works. For example, Different manufacturers do implement parametric equalizers in different ways. And those parametric equalizers, although they may have the same controls on a front panel like boost and width and frequency, they do not yield the same equalization curves in practice, and that's what creates the unique sound and quality of these devices. And AES70 does not attempt to standardize the behavior of those. So AES70 gives you the equivalent of those three knobs, but it doesn't say what those knobs exactly have to do. That's your business, the manufacturer's business. What's also not in AES70 are standardized profiles. In other words, we don't get into the business of saying, if you build a mic preamp, here's the way the functions have to be arranged or should be arranged or anything like that. Those are outside our scope. Really, what AES70 just does is produce a toolkit for what you can put in your device to make it network controllable. The AES70 family of standards, it contains at present these standards. Not all of them are published. You'll see where it says new there. Those are not yet published. But the core AES70 standards that exist now are AES70-1, 2, and 3. And AES71 is about a 60-page text document that explains how AES70 is put together, the basic mechanisms, how this talks to that, how devices are constructed and so forth, or at least it isn't how devices are constructed, it's how the control interface for devices are constructed. That's AES70-1, we call it the framework. AES70-2 is called the class structure. This is an object-oriented term, but what it means is that this document defines the actual control and monitoring repertoire. You know, this is the document that says, here's how you control the gain control, here's how you control a delay, here's how you control a parametric equalizer, here's how you control a dynamics device, etc. It's this AES70, the class structure is currently described in a language called UML, which is it stands for Universal Modeling Language. It's a kind of a graphics language. If we have time at the end of the presentation, I can put some of this stuff up on the screen, but UML is a time-honored computing industry tool for describing programs and processes and designs and stuff, and it's very powerful and flexible. In the future, though, we're probably going to go away from UML to something more text-based. I can talk about that later. But modern programming techniques are leaning toward other ways of describing control repertoires and interfaces and stuff. So that may change, but it's not going to change soon. If it's going to change, it'll change in a year or so. But at the moment, to use AES70, what you need to do is to get a universal modeling language reader, and those are good ones are available free, and the standard documents describe how to get them and so forth. AES70-3 is the binary protocol. This is actually, the top two documents do not talk about what goes over the wire in detail. They just say there are commands and there are responses. But the AES70-3 is a binary protocol definition. It defines a protocol called OCP.1, which is a protocol using small, compact, high efficiency binary elements. And these elements are what flies back and forth across the wire. There are basically three kinds. They're called commands, responses, and notifications. AES70-4 is a new document not yet published, which will define another way of talking to AES70 devices, an optional way called OCP.2, which uses the JSON text-based language. For those of you who may be familiar with web-based programming and so forth, there's a popular way of communicating object-oriented values across networks these days. And it's called JSON, which stands for the JavaScript Object Notation. It's something that came out of the JavaScript programming language, and it's text. So OCP.1 is a compact binary representation of the commands and responses and so on. OCP.2 is a text-based way of representing those same commands and responses that perhaps more friendly to some programmers, although that takes a little more network bandwidth and a little more computing to unscramble it at the other end, at each end. Then there are two more standards. They're called adaptations, and what the term adaptation means in AES70 speak is that when you take AES70, which is a control language, and you want to match it up with some kind of media transport scheme like AES67, then you need a document, you need a standard to describe exactly how the AES70 features will, for managing connection. AES70 includes features for managing connections. There are commands like, make connections and connect this and disconnect that and so on. But those are general, and they're designed to accommodate any kind of media transport protocol. So the adaptation is what they call in networking a profile, which means it's a document that says, okay, here are all these general features. Here's how they're used for AES67 in the case of AES7021. Here's how they're used for Milan in the case of AES70-22. If you're not familiar with Milan, it's a new initiative by audio manufacturers, most of whom are large concert loudspeaker manufacturers, to produce a protocol based on what's called the AVB standard. It's another way of sending audio around besides AES67, and it's a little more potentially a little more precise in its timing, so that for people that are creating large arrays of powered loudspeakers or large arrays of loudspeakers that are driven by many channels of separate power amps, where the timing relationships are really critical in order to achieve the beam steering goals they want to have, the beam steering functions they want to present. These guys have gotten interested in Milan, and so there's this other way of sending audio around. The other elephant in the room that's not in this list, but will be in a future list, is Dante, which of course Dante is yet another way of sending audio around. It's very popular in the pro audio community, and it is expected that a Dante adaptation will also be defined at a later date. Certainly, AES70 is very friendly is very compatible with such a standard. So AES7023 most likely going to be a Dante adaptation. The version status of everything, AES70-1, 2, and 3, you can see are currently at version at the 2018 level. So there's AES70, the full ID of the standard, the AES70-1-2018. AES, is a typo there. That's supposed to be, hang on a minute, whoops. Hang on a minute, let me fix this right now. This is supposed to be 2, and this is supposed to be 3. There we go. The current standards, these are the ones that are published and available through the AES Standards store, are here. The other ones are not yet published. And the kind of anticipated dates, I'm saying February. This should probably be March. Actually, this is an older slide before we, you know how things go. So yeah, probably March is more like a date for those things. These things are released in March. And then all these other standards, -4 and 2020 and 22, depend on the first 3. So they cannot be released before the first 3 are published. So they'll be released at a reasonable pace, I don't know what, once a month or something, who knows. All these developments are currently ongoing. Every one of these 6 standards you see is currently being worked on by somebody. There are a couple different groups involved. Oops, sorry, that's the wrong button. This button. You see floating around AES67, you'll see it quite commonly, the term OCA. People familiar with the history of things will know that AES70 began life as a thing called OCA, which is the Open Control Architecture. and it was the project of a trade association called the OCA Alliance. The OCA Alliance originally started up OCA in about 2011 with the idea that they would develop a specification and then offer that specification to the AES to be turned into a standard, and that in fact is what happened. And so they did that in about late 2014. The original OCA spec was given to the AES, and the AES published it as AES70 2015, which was the first version of AES70, and then it was later updated. Today, the OCA Alliance continues to develop these specifications and forward them to the AES. So as a matter of fact, most of the development of the core standards, to go back one slide, the development of 1, 2, 3, and 4 is being done by the OCA Alliance, and will soon be transferred to the AES. The adaptations are being done by the AES, as it turns out. It's just the way the work worked out. But so OCA is the technology that AES70 standardizes. It was originally developed by the OCA Alliance, is now standardized in AES70. The word OCA, however, still exists and has gained a larger meaning. It has become the name of an ecosystem that surrounds AES70, because the OCA Alliance and other contributors to the OCA Alliance are developing other things that are outside the standard, like tutorials and tools, software and all that stuff. And so the general idea is that OCA now means this nice ecosystem that includes AES70 as its official specification, but includes also a lot of other less formal work. There are 2 websites. There's the regular website of the OCA Alliance, which is this one. I was using it there. And then there's a separate technical site, which is based on GitHub. That is a place where we put a lot of open source software, more program oriented features and stuff. And both these are public. The OCA Alliance has members, but and the members are the ones that are responsible for development of this stuff. But almost everything the OCA Alliance produces is public. There are a few things that are members only. We have to make it worthwhile for members to be members, but by and large, it's all public. I'm the chair of the OCA Alliance Technical Committee on the OCA side. On the AES70 side, I'm the chair of a group called SC02-12L, a standards task group that is responsible for the AES70 family of standards. What's good about OCA? Here are some good things about OCA. Open and license free, oriented toward pro applications. This is not a home protocol. This is not, you've heard various other home protocols like DLNA and all names like it's not that. Scalable up to huge network sizes, suitable for mission critical applications. Those are important for example, paging systems and that are life safety certified. Also big broadcast applications that cannot fail. You don't want things to fail in the middle of the Olympics. AES70 is friendly to proprietary product features. One of the outgrowths of good object-oriented design is that extensibility kind of comes for free. Future-proof because it's extendable. Secure. There are secure options. Able to support dynamic device reconfiguration. They're in the recent years, our devices have become more and more virtual. Now there are completely virtual devices that are running in the cloud and so on. And these things are very flexible. The functions can come and go. They can be reconfigured and reorganized by controllers and users on the fly. And AES70 is probably the only existing media device control architecture that fully supports dynamic reconfiguration. It was designed that way from the start. And also heterogeneous network capable, by which I mean that AES70 not only can run on IP and non-IP networks. And so if you have an IP network that includes a bunch of devices, but then there's some other stuff out at the ends of USB links and so on that you also want to control, that AES70 will be able to reach those and deal with them in a consistent way. Well, there are other advantages. I think this isn't the fully complete list, but to give you an idea, It's an industrial strength design. So what is in AES 70? Let me switch my time here. Well, in AES 70, in an AES 70 device, there are things called objects. And if you look at the blue box down here, down at the bottom, which probably should have been at the top of this slide, an object in AES 70 terms is not necessary. It doesn't always relate to a real thing inside the device. And an AES 70 object is a little application program interface that's presented by the device to the network. So you can think of an object as a little bunch of functions that live just inboard of the RJ45 connector. And when you if you're a device designer, when you pick an object, when you say, I'm going to, for example, there's an object called OCA gain. That's a gain control, okay? And OCA, what's OCA gain? Well, it's a little object that, it's a little application program interface that lets you, that has a property called setting. And if you change the value of that property, you're going to change the value of a gain somewhere in the device. Or it might be a stereo one, and changing the value of that property might change the value, two gain settings in the two object channels, or for that matter, it could be a 10-channel gain control. And when you change the setting, you change the gain of all 10 channels. But in all those cases, the API is the same, because the API is an abstraction for a gain control function. So an AES70 device is basically, if you look at it from the network side, if a controller is looking at an AES70 device, it's kind of a box of objects. And every object has a unique identifier. So this is gain control. And if you have a whole bunch of different gain controls in your object, you might have you would have a whole bunch of gain. If you have a whole bunch of gain controls in your object, you need to independently control. Then you'd have a whole bunch of gain objects that you put in your control interface, and each one would have a unique number, and so on. Object can be more complex. For example, if you have a parametric equalizer object, it's going to have, I think there are actually 4 parameters that the AES70 parametric equalizer gives you access to. There's boost and cut, there's frequency, there's Q, and then there's another one, I think it's called a shape property, that lets you change the shape of the curves if you need to. It's a device dependent way. So these objects can be complex. It's not necessarily true that one object corresponds uniquely to one parameter. There are categories of control objects that you can put in a device. There are managers that are standard housekeeping objects. So for example, if you want to know, if a controller wants to say, okay, what's the serial number of the device I'm talking to here? Or what's the model number? You know, what version of the software is it running? All that stuff. You can find that out from a manager. There are worker objects that are objects that correspond to audio processing functions. That the gain and parametric equalizer examples that I just gave are worker objects. There are things called agents that kind of help the workers out. They don't represent any audio functions themselves, but they help out. For example, there's an agent called a ramper that lets you tell the device to adjust a property gradually over time. So if you want to have, for example, your device do a gradual fade, a level fade, with you can put a ramper agent in your device that you can tell to do this fade over the next 5 seconds or something, and so the controller doesn't have to keep sending millions of commands to the gain control saying, okay, another 1/10 of a dB down, another 1/10 of a dB down. You don't have to do that. And then there are network objects that are used for controlling connections. So if you want if you have an AES67 device that you want to connect and disconnect to this place and that place, and you're routing your media streams here and there, you can control that connecting and disconnecting activity using AES70 network objects. And all these things are pretty much freely controllable or freely configurable. You can, in other words, it's sort of like AES70 is kind of like a catalog. You know, you go in there and you say, okay, I need 3 gain objects, 2 parametric equalizers, 4 switches, you know, and you put them in your device, kind of in the same way that a hardware designer would pick integrated circuits and resistors and capacitors and stuff out of a catalog and hook them together. Inside each control object, this is now standard object-oriented design. A control object has some unique, has some features, right? The controller has properties, which are variables that define the state of the object. For example, the gain control has the setting property. Parametric equalizer control has the properties I mentioned, frequency boost and all that. There are methods, which are operators that change the properties and cause actions. And the methods are the subject of commands. So when a controller sends a command to change the gain, it in fact invokes a method to change the value of the setting property. There are events that are signals emitted by objects to indicate state changes. This is particularly important for monitoring. For example, you know, there's an object as a monitoring object in AES70 called audio level meter that sends out signal level changes. And so this is, you know, so you get from these audio level meters a stream of events. The controller will receive those and can use those to update a level meter bar graph or something on the screen of the controller. This is how controllers can watch stuff going on in real time in devices. And there are ways of controlling the frequency, the repetition rate of all these, so that you don't get them too often or too infrequently and all that. I won't get into those details, but basically these objects can cause events. Other events can be one-off type events. For example, I've just gone over temp. You know, if you stick a temperature monitoring object inside your device, it will be able to report back to the controller when it gets too hot. And then as I mentioned, I think above, every control object has a unique object number within the device, a 32-bit integer that distinguishes it from everything else in the device. But remembering, just reminding you again that when we say a control object, we really mean a little application programming element. So if I have my gain object, there's a gain object could be controlling a DSP function. It could be controlling a gain controlling electronic voltage controlled gain control IC, or it might even be controlling the motor in a motorized fader. All those details are invisible at the control interface, and the same gain object is used to control all those different kinds of gains, for example. A class, now how does OCA organize all its repertoire? You know, so how do you know there are gains and parameters and all these things I've been talking about? The answer is that it uses the object-oriented principle of classes, and a class is a template from which an object is created. So NCA gain that I've been mentioning is in fact the name of a class, and every class is uniquely identified by an ID, and if you know the NCA gains ID, I think is something like 1.4.1.1, and I don't want to get into what that means, but controllers can look through a device and say, oh, what kind of object is this? Oh, it's a 1.4.1.1. Okay, I'm gonna look at my tail. Okay, it's a gain control. You know, what else and what else? Everything's identified. There's a thing in classes which is very nice, a feature of object-oriented design called inheritance, and it means that you can create a class from another class. My example of that I generally use is, what if your device has a stepped gain control, and in fact maybe it's a DSP type stepped gain control where you want to be able to adjust the step size by the controller. So one day the controller wants to move the gain in 1 dB steps, and another day it wants to move it in half dB steps. How do you do that? The standard object AES70 definition, the standard AES70 class NCA gain does not include that feature. The way you do it is you say, I'm going to create a new class that inherits from NCA gain, and I'm going to call it It'll be a proprietary class. It won't be necessarily part of AES 70. But it'll be in my device, and I'm going to call it NCA stepped gain or my stepped gain or something. It doesn't have to begin with NCA. And it'll have its own class ID and it'll be related. So if NCA gain is 1.4.1.1, then I make a new class, I add another level on the end, and I make it 1.4.1.1.1. And that'll be my class, and that'll be for my device, and that'll be NCA step gain. Now I've oversimplified this a little bit because in fact, in these codes, these 1.4 things that I've been mentioning, there are in fact manufacturer's IDs scattered in there, so that if I invent a kind of step gain control and somebody else in another company invents another kind of step gain control, and a controller is controlling both of them, it will not get confused. So everything's disambiguated by manufacturer for proprietary editions. I just won't get into those details, but the idea is this inheritance makes things very nice for proprietary extension. It also makes things very nice for growth in the future. So if we in the future, as part of a new AES 70, wanted to add a step gain control, we could follow the same do the same trick. So the entire set of OCA classes, and there are about 100 of them, defines AES 70's functional repertoire, and there are classes for controlling, classes for monitoring, and these agent and manager classes for handling other details. The object model is going to evolve. There are rules about inheritance that mean that when you create your own class, or when we create a new version of an old class, there are rules that guarantee, or pretty much guarantee, that the new classes will be at least somewhat controllable by an old class. So for example, a controller that knows how to control NCA gain but not NCA step gain will still be able to control the gain part. It just won't be able to change the step size. And I've sort of said this already, the proprietary classes become gracefully addable. So watching my time here, I'm not bad. I mentioned before events, that devices have to be able to send back news to controllers without controllers necessarily asking for them all the time. You definitely do not want controllers to do what's called polling, which means every 100 milliseconds they go and ask the device what it's up to. There are older kind of control regimes that work that way, and going back a couple decades, and the problem with that is it just burns up resources and so on, and just gets completely out of hand when devices get complex. I mean, if you look at something like a mixing console, it's probably going to have 50,000 objects in it or more, and you can't be asking 50,000 things what their state is every 100 milliseconds. So instead we have events. An event is a transient state of an object that can cause it to send one or more event notification messages back, and the notification is the command that goes back along the wire to the controller. Different classes, we were mentioning classes before, have different event types. And event definitions are inherited. And probably the most common, most important event is called property changed. And this is an event that causes an object to emit a notification whenever a value of any of its properties changes. So for example, I mentioned this VU meter, the audio level meter object, it's going to emit a notification whenever the audio level changes. Now, as I said before, there are ways of filtering that to make it less frequent. Don't worry about that. But the basic idea is that an object emits a notification when its value changes. However, the fact that object can emit the notification doesn't mean that it does, because there's a subscription mechanism. So a controller has to tell an object that it wants to hear about its events before the object will actually send. So if I have a controller, if I have a multi-channel device, and for some odd reason, a controller that I'm using only supports channel A and doesn't care about the other channels, there are ways for that controller to only be notified of changes in channel A. And also the subscriptions are object by object. So you can watch a level meter, but you may not want to watch a gain control. Events are a really important feature for a variety of reasons. One is scalability, the way I mentioned, so you don't have to poll everything all the time. But the other is that events, property changed events in particular, are the primary way that OCA, the AES70 supports multiple controllers. If you have a bunch of controllers controlling a large system, all the controllers have to find out whenever one of the controllers changes something, a value, a control parameter that they care about. So, the way these controllers do this is they subscribe to the particular objects and properties and stuff that they want to know, they want to watch. And then when any one of the controllers changes one of those important property parameters, all the other controllers get notified, and that way all the controllers can stay in sync. So let's look a little closer at the repertoire, just to try and give you a sense of what you can actually do with AES70. The control repertoire is divided into, and this is what's defined in AES70-2. Right? So the control repertoire is divided into workers, agents, networks, and managers. Workers are the ones that are the real audio-oriented things. And so workers are divided into three categories: actuators, sensors, and then a third category called blocks and matrices. It's a little bit different. I'll describe that. And then there are agents, which are, the way we define an agent is something that affects the flow and timing of control, but not directly. Agents don't directly affect audio. Networks are for connection management, and managers are for device housekeeping, as I say, all together. And so now to look at, here are some workers. Okay, here are the actuators that are defined. These are classes that control audio processing fundamentally. And you can see, you recognize, we tried to make these familiar audio concepts. On the left, you see mute, polarity, gain, band balance, delay, frequency, and so on and so on. All this stuff, all these familiar things. There are a few, there are some upcoming ones also in the future, in the next release of OCA, but I'll talk about that a little bit later. So there are all these controls here. And then over on the right, there's a set of basic controls, which are, what if you're a device designer and you look in this list and you don't find something you can use? So let's say you're designing, well, give me an example. Right now, there's no basic class for a reverberation processor in the actuator. So what if you're designing a device that has reverberation in it and you want to control the reverberation? You can't find one of these standard objects on the left. You're not sunk, because what you can do is you can look over on the right, and there are all these basic actuators that just control basic data types: 32-bit integers, unsigned integers, floating point numbers, string actuators, booleans, and so on. And you can just allocate a bunch of these objects to control the parameters of your reverberator. So these things on the right, these basic actuators, are kind of an escape into a lower level kind of representation for things that aren't covered by these more elaborate, as they say in computing, strongly typed classes over on the left. And each one of these is the name of a class that is in the AES70-2 class structure. That's why all these names to begin with OCA are names of classes. The sensors, here's more work. Here's the sensor ones. Here's OCA level sensor and a specialized version of it called OCA audio level sensor. The difference is that level sensor is kind of a dumb sensor. It just reports a signal value. Audio level sensor is the one that has the metering laws of decay and peak detection, PPM and VU laws, stuff like that. Time interval sensor, frequency sensor, temperature identification. An identification sensor is an example of a thing that probably should have been an agent in retrospect, but the idea of this is that you can push a button on an audio device. It'll send a signal back to the controller. So if you have a million devices and you're trying to figure out which one is which, you push a button on one and the controller says, oh yeah, okay, your device number 30. And then there's a set of basic sensors, again, that mirrors the other set of basic sensors for sensing things that aren't covered in the standard classes. Now, blocks and matrices is a powerful concept that really I just sort of touch on a little bit here, but the idea is this: what if you have a 64-channel console and every channel is the same as far as what it does? It's got the same controls and so on. You want to control it the same way. You know, it's got a master gains and trim gains and equalizers and who knows what, routing selectors and mutes. And so how do you do that in a way that's not too tedious? Well, what you can do is you can define what's called an OCA block that's a container for workers, agents, and networks. And you can put into that block all of the functions that a channel has. And then you can say, okay, replicate that block 63 more times. And so you end up with a control interface that has all 64 channels in it, but you didn't have to code each one in detail. Blocks are also particularly useful if you have dynamic devices. What if you have a virtual mixer that's running in the cloud or something that's got 32 channels, and all of a sudden you want 32 more? There are primitives in OCA saying, okay, make 32 more blocks on the fly, if your device supports that. Block factory is the thing that makes blocks, is kind of what I just talked about. And matrix is a different, matrix is a thing that represents a classic matrix. It's a two-dimensional thing. And at each cross point, there's a function. The difference between an AES70 matrix and most ordinary matrices is that you can specify at each cross point very complicated things. You can put a whole block at each cross point. So you could make a matrix that contained, let's say, a gain, a delay, and an equalizer at every cross point. Also, matrices are multi-channel things, so you can have a single matrix that was a stereo matrix or a 4-channel matrix or a 2-in, 3-out matrix. You can make all of those things with the same mechanism. And as I say, you can put arbitrarily complicated processing at each cross point. It has to be the same at every cross point. You can't have one cross point with a gain controller and another cross point with a gain and equalizer or something. You say, here's what goes at every cross point of this matrix. You can, of course, have any number of matrices in a device. So, there's no limit there. And then in networks, there are, these are connection management. There's the idea, this is the idea of OCA application network, which is a basic network that contains everything. And then there are control networks, which are the networks that AES70 uses to send stuff back and forth. And there are media transport networks, which are like the networks that are used for media transport. And this, as I say, AES70 does not define media transport. It just defines ways of controlling it. So there is no sample transport scheme inside AES70, but you can use a media transport network to control your AES67 functionality in a device, for example. And that how you do that is the subject of those will be the subject of that standard called AES7021, which is an adaptation that defines how you use media transport network parameters to control AES67 transport. I realize I'm going pretty fast here because there's a lot. I don't want to, and I haven't bothered to detail all the managers. That's pretty boring stuff. But this gives you an idea of what you can do in the sort of application and functionality department. Now, let's look at the device model. What is it? What do we mean by device model? It's what it means. What's inside a device. So as I've been sort of saying all along, you're going to create a device by picking and choosing control objects to put inside the device. But there's kind of a basic form of a device. A device is not a completely blank slate. So there's what's called a minimum device. Here's the stuff that you at least have to have in every device. And then on top of that, what else? So here's the basic picture. there are some here, each one of these squares is an object. And in a standard AES70 device, you need to have a device manager object, a security manager object, and a subscription manager object. So, the device manager is like where you find out the serial number and software version and stuff. Security manager is where you control security, which I won't bother to get into the details of that in this presentation, but it's there. And the subscription manager is how controllers subscribe to the things they want to watch, as I described previously. A whole bunch of other stuff is optional. And this, in fact, this is the AES70 2018 version of this. I have to qualify this. In 2022, this will change a little bit. Not, these three will still be the same, but the optional ones will be different. And then in addition to that, of course, you have to have all of your objects that actually represent application functionality. So over here, the red things are the gain controls and the equalizers. The green things are the agents, such as this one that I described that does automatic fades. And the networks are the blue thing down here are the things that control your transport connections. You can see all the optional managers over here. There's clocking and processing and things that managing power supplies, which I notice I've listed twice in the same list. Sorry about that. But you know, I'm not going to go too far into those details. But this gives you an idea of what you know when you start to make a device. Say, okay, I'm going to need a device manager, security manager, subscription manager. Now let's see. Well, what workers do I want to have? All right. Well, I want to control this application function, that application function, that one. So I need this one, this one, this one. Whatever you want to control. If you have functions, excuse me, in your device that you do not want to be network controlled, well, maybe you have something that you only want to control by a front panel switch or an internal jumper or a proprietary software interface or something like that. You don't want to be AES70 controllable. You just don't put those objects into your device model, and then there's no way that an AES70 controller can even know those functions are there. By the way, speaking of knowing functions are there, the AES70 does contain complete features for controllers to discover what's inside a device. So for example, we have an application called the AES70 browser that you can hook up to. It runs on a PC, and you hook it. It's a controller, and you hook your PC up to an AES70 device or set of devices, and it'll go around the browser software. It'll go around and discover all the objects that are inside all the devices and put them up in a kind of a tabular interface. It's a programmer tool. It's nothing you'd want to give to users, but it just allows you to see everything that those AES70 devices present on the network. You still can't see the things that aren't presented on the network, as I was saying before. Nobody can see that except for whatever methods there are. But the AES70 browser does use standard AES70 features to discover everything that's all the AES70 functionality inside a device. We're getting close to the end here. The AES70 2022, I just wanted to put up a little bit of a sneak peek. And here's the sneak peek. What's in AES70 2022? This doesn't look like a long list. There's actually about somewhere on the order, if you include all the documentation changes and tweaks and fixes for mistakes we found in the previous spec and all the other, and new class and new standards. So there's probably about 150 changes to AES70 22. We have a big spreadsheet that manages all this stuff. And some of the changes I say are trivial, and some of them are just documentation changes, but a lot of them are functional. So these are the functional changes that are listed here. First of all, media files. There's going to be a way. There's in fact there's a more general mechanism underneath this, which I can describe. But basically, media files are ways that a device can store and play back a media file, and there are ways to control that with AES70. So you could now, using AES70 22, control a media server, which would have been not completely supported in previous versions because previous versions didn't have the notion of a media file built into AES70, but now there is, and so there are operations for uploading and downloading these files and playing them back and stopping and starting playback and whatnot and identifying them and so forth. So that's the first point there, media files. The second point is logging. AES70 2022 will include ways that devices, the software inside devices or firmware can create log files, and those log files can be accessed by the controller and cleared out and so on, the normal log retrieval. And there are some efficient log retrieval mechanisms in there. So if you have a large log file and you only want to retrieve the most recent part of it, or only want to retrieve certain kinds of events, and you can. There are ways of turning logging on and off. So if you're finished debugging, you don't need all the logs, you can turn them off and so forth. So those features are in there. Another big new feature is called command sets. And this will allow controllers to store predefined sequences of command sets in the device and execute them at a predefined point or immediately. I mean, you can say run this command set now, but a controller can also say, here are 10 commands that I want you to execute tomorrow at noon. And this feature will allow that. And the other thing this feature will allow is to allow executing command sets at predefined points in media streams. So if you have a stored media file, and you want the device to execute some particular commands at a particular point in the media file, you can do it. So a fairly powerful feature. The next point is streamlined connection management. We've improved the connection management stuff quite a bit in AES70 2022. This feature set, this connection management stuff, this is the feature set that allows you to control what's happening with your AES67 and Dante streams, SMPTE 2020, 2110-30, all these different media transport forms. This is the feature set that allows you to control that. We're actually at revision 4, so the new feature set for media connection management in AES70 2022 is going to be called AES70 CM4, and CM4 is a powerful way to allow applications to control media routing, media flows, and so forth. A new part of that is called connection negotiation support. There's now some very nice new features in AES70 that allow controllers to talk to devices and just figure out exactly what kind of sample rates and coding schemes and latency parameters and stuff that the devices need to successfully communicate streams. If you worked at all in AES67 or in broadcasts, when there's a world of different formats, particularly when if you go a little beyond AES67 and use codecs to have encoded streams like MP4 streams and so on. There are just so many ways of representing media streams, so many standards for clocking, 44.1, 48.96, and so on. And all these things for two devices to decide whether or not they can successfully talk to each other and to pick the best set of parameters for doing that, for setting the highest quality media possible, given their capabilities and the network capabilities and stuff. It's a complicated process. That whole connection negotiation process is complicated. So we've added features in AES70 so the devices can do a really good job of describing what they're capable of, and then it makes life easier. Then there's new support for handling stored parameters. We had a mechanism in AES70 2018. What I mean by stored parameters are things like presets, where you say, okay, I want to change, when you load a whole new console preset into a mixing console, and in a total recall kind of console, every parameter in the console could conceivably change. Or in what might be a less complicated example, you have these DSP power amplifiers now, and you want to load a whole new set of DSP parameters into these power amplifiers, depending on the nature of the array, loudspeaker arrays and venues and stuff that they're being used with. So we had a mechanism for that in AES70 2018, but it wasn't powerful enough and wasn't general enough. And so we have a whole new mechanism now that is much better and can handle extremely large parameter sets or extremely small ones in a simple way. And then beyond that, there are dozens of small additions, ease of use improvements, documentation improvements, and so forth that'll be coming along. And I guess the last thing I'll mention that isn't on this slide is that what's also going to happen after AES70 2022 is that there's going to be it's spearheaded by the OCA Alliance, there's going to be a major AES70 education initiative. So all of this stuff, all these icebergs that I've kind of mentioned the tops of in this presentation will be elaborated. There's going to be a lot more tutorial material available and videos and all this stuff that is going to make AES70 a lot more accessible, because over the years, AES70 is, I think you can probably see that AES70 has grown to be quite a large specification, and it's no longer at all acceptable for us to say to prospective new users, well, just read AES70-1 and it'll tell you everything you want to know. So that doesn't work. So there's going to be a lot more training, tutorial, explanatory material, piecewise presentation of feature sets, so you don't have to swallow the whole thing in one gulp, and so forth. All that is part of the education program that's going to happen, probably beginning second quarter of 2022. We haven't planned it all out yet. We just defined our intentions to do that, and it's primarily that those discussions are going on in the OCA Alliance right now. But certainly the AES will have a full dialogue with the AES about how the AES participates, possibly through seminars like this and other ways as well. So I think that's about the story.
We have a couple questions, Jeff.
Okay, let's proceed. Let's see. Do I read these questions? Is that how that works?
Yeah, so we can answer these live. So the first one was, what's the relationship between AES70 and NMOS?
Okay, good question. I'm also working, the relationship between AES70 and NMOS goes like this, that the existing NMOS, I'll try and make this short. The existing NMOS standards are primarily oriented toward connection management and a small amount of monitoring in the way that AES70 does. But what's happening now in the NMOS group is there's a new initiative in NMOS called the NMOS Device Model Project. And the objective of that is to produce a control standard, and it's going to be a lot like AES70. The reason it's going to be a lot like AES70 is that AES70 is freely contributing technology to that work. I'm involved majorly in the design group on the NMOS side for that initiative. You can read there. It's being called NCA, the NMOS Control Architecture, and NMOS has already the MWA has already released early preliminary results. MWA works very publicly, so you can see early drafts and things on their on their website. So and that when that protocol is published, it's going to be very similar to AES70. My personal hope is, and that's how real device control is going to come to NMOS, because real device control hasn't yet, with the current NMOS suite of IS 4, 5, 6, 7, and so on. Full device control isn't in those specifications, but it will be in the NCA specification as it evolves over the years. And it's going to take a few years for NCA to catch up to AES70 as far as functionality goes. And during that time, I'm going to be working to try and get those two specifications as converged as possible. And as I say, I'm the primary author of the NCA framework document, the NCA sort of equivalent of AES70-1 is already available in public draft from AMWA. And you'll recognize, if you look at AES70 and you look at that document, you recognize great similarities. And of course, that's because we just, in the NCA group, we just imported as much as we can, because it's a whole lot of work to design something like AES70, and the NMOS guys don't have time to start over and define something totally different. And so we were able to really contribute a lot of technology. So the answer is that right now the existing NMOS standards describe a kind of certain aspects of control. The NCA standards they're working on will be much fuller. And those NCA standards will be as compatible with AES70 as we can make them, and we're going to be looking at ways of converging them in the future. If you want more detail about that, please, you can contact me directly, no problem.
Okay, we have another one that is a little bit more complex. For example, if you've got a portable camera that uses AES67 for the audio transport, can you also have the capability to have its audio controlled at the camera by way of AES70 being carried by way of the AES67 connection? So I think we've kind of mashed together the transports.
Bruce, this is not a difficult question. The answer is that AES67 is a function that runs over an IP network. So is AES70. We all experience every day the fact that an IP network can carry multiple things at once. Just look at if you're running a web browser and getting email and playing a video game at the same time, there's all kinds of different traffic that's running along your network connection out of your computer. So AES70 is just one more kind of traffic, and so is AES67. So those run quite happily on the same network link. And so
that's why I say we don't want to confuse. AES70 isn't being carried by AES67. In fact, both of them are transported across the wire at the same time. Yes. So if this camera is a AES70 controller, then of course it can control these connection management things at the same time, because they're both living on the wire at the same time.
Yeah. I hope that let's make sure that answers the question, though. Does that answer? Okay, let us know if that doesn't answer the question.
Yeah, he just replied. That ties it together. So that's really what we want to talk about. Is that these are both IP protocols that are living on the same network at the same time, and who's controlling who is defined by the manufacturer that's implementing either one or both of these protocols.
Right. Now, I see another question from Richard Foss here. How does the object ID of an object relate to the class ID of the class it comes from? The answer is that, excuse me, the class ID is a sort of a little data structure. As I said, it's a sort of you can think of it as a multiple decimal point number, like 1.4.1.1 means NCA gain or OCA gain. I mean, that's a gain control. 1.411 is a gain control, and all gain control objects will have that same class ID. So if you have a device with 50 gain controls, all those gain control objects will have the same class ID, 1411, which means I'm a gain control. And all of the parametric equalizer controls that you put in that device, if 1.4.1.6 is a parametric equalizer, let's say, I'm improvising, then all the parametric equalizers will have a class ID of 1.4.1.6. However, the object ID is a 32-bit integer, unsigned integer, and it's different for every object in the device. And it is allocated, it's up to the device how to allocate those numbers. They just can't use anything smaller than 4096. And so every gain control, the gain controls might be starting at 1 million, 1,000,001, 1,000,002, 1,000,003. They don't have to be consecutive. And the parametric equalizers might start at 500,000 or 5,000, and all those object ID, as long as they're unique, can be completely controlled or completely determined by the device designer in any way that makes sense to them. If they want to attribute special significance to the object ID values that's inside the device, they can, or if they just want to start numbering it at 4096 and go up, they can do that too. And Richard, another question. Has there been any work to create AES70 proxies for current mixing consoles? Not that I know of. Probably because the OCA Alliance, the only maker of mixing consoles in the OCA Alliance that I think of right now, I think this is true. Well, Bosch makes a few little mixing consoles, but they're tiny little mixers that are not, they're analog, they're not even digital. But the only serious console company I think is Yamaha. If I'm forgetting somebody else, I apologize. And Yamaha has a lot of irons in the fire, and they haven't made a major commitment to AES70. AES70 is one of their many interests. So I don't think so. But I mean, maybe. I haven't done one myself. As a matter of fact, the only real AES70 device design I did was I designed an AES70 Pro control profile for an espresso machine years ago, just to demonstrate that AES70 is pretty flexible. So that was humorous, but it's available if anybody wants it. But no, I don't think so. Any other questions? I don't see any other questions in the chat. I don't know if there are other channels by which questions are received or not.
Well, the Q&A is the best place.
Okay. I don't even know.
And we've dealt with those three. So
Okay.
if there's no other questions forthcoming, I think we'll end it here then.
Okay, let me just point out, I just added a minute ago, you might have seen it. My email address is here, and really people should feel free to contact me. Standards is a large part of my job, so I don't have to find spare time to answer your questions. I'm paid for it. So please feel free to contact me. That's all.
A copy of the presentation is available on YouTube, and
the view graphs will be posted on the AES website soon.
Right.
As soon as Jeff gets me a copy, we have a page that carries the graphs from all the previous presentations. So if you go to AES Standards homepage, you'll see down at the bottom a segment that says download data files, and it should be down near there in that area.
And that usually comes up in that'll get put up in the next week or so, right, Rich?
Typically a few days.
Yeah.
Cool. Just want to acknowledge the people that say thanks, to say you're welcome. This has been fun. Hope to talk to you again soon about some of these topics in more detail, maybe. Certainly we should have something after AES70 2022 is released to actually confirm what features are there and all the details that I wasn't able to present today.
Okay, we're done. Thank you, Jeff.
Okay.
Okay.
Bye-bye.
Bye.